Now here let us solve one sum based on the binomial distribution. 10 fair coins are tossed simultaneously. Find the probability of getting exactly 2 heads and at least 2 heads. So here we have two sub questions. Now if we see that the tossing of a coin is an event which has only two outcomes, it is heads or tails, then we have 10 coins. That means the number of tosses are finite, and as we know that each toss is independent and the probability of getting heads and tails remains same for any coin in general. So that means we see that this particular experiment given includes the Bernoulli trials, right? And we have to find the probability of getting exactly 2 heads and at least 2 heads. So first of all, let us define what do we mean by success and failure. All right, so let us denote success as nothing but getting heads, and obviously the failure becomes if we get tails. Now we know that probability of success is denoted by P, which is half, and probability of failure also is half here because heads and tails have 50% chances of appearing. Also we have the number of Bernoulli trials to be equal to 10 because we are having 10 coins for toss. So the first question is probability of getting exactly 2 heads. So that is probability of x equal to 2. Now just to recollect the formula for binomial distribution, that is probability of x to have the value as small x is given by NCx p raised to x into q raised to n minus x. Alright, so therefore here probability of getting 2 heads or 2 successes is 10c2. Now p is nothing but half raised to 2 and q is also half raised to 10 minus 2. Alright, so that gives us, now 10c2 is 10 into 9 whole upon 2 into, now if we observe we are going to get 1 by 2 raised to 8 as the second term, and that when added with 2 ultimately we will get 1 by 2 raised to 10. And we know that anyways from binomial theorem, that is sum of the indices of two terms is always equal to n, so that automatically comes to 10. So here we can cancel out 2 and have 5 into 9 is 45, and that divided by 2 raised to 10, which is nothing but 1024. Now as we see 2 raised to 10 is nothing but a number having only 2 as the prime factor, although it occurs 10 times, and 45 is not divisible by 2, so this is already relatively co-prime fraction. Okay, so therefore this is the required probability of getting exactly 2 heads. Right. Now if we see the second sub question, that is, now the wording is slightly changed and it is at least 2 heads. So by at least 2 heads we mean there can be either 2 heads or 3 heads or 4, 5 or any number of heads up to maximum 10 heads. So that means for each of that case we have to calculate the probability as we did here for x equal to 2. So same we have to calculate for 3, 4, 5 and so on up to 10. Now we know that of course this is a very tedious approach, and we can get the required answer by an indirect shortcut, that is as this. Now to have at least 2 heads is nothing but probability of x greater than or equal to 2. Alright, now that can be written in other way as 1 minus the probability of unwanted outcome. That is, what is the case which is not included in x greater than or equal to 2? So that is obviously nothing but x less than 2. This is what we don't want. So that we must subtract from the maximum probability 1, right? So therefore it is equal to 1 minus. Now this further can be written as x less than 2 means x is either equal to 0, that means we don't have any success, that is we don't have any heads to appear, and it can also mean that x is equal to 1. So we have just one success, that is only one head occurs. So this is what we have to calculate. Now this is easier to calculate, as we can see the numbers will be relatively smaller here. Now to get x equal to 0, once again we substitute, that is 10C0. Now you see P and Q are both going to be 1 by 2 and their sum of indices is going to be 1 by 10 only, as we have seen earlier. So this is going to yield us 1 by 10 only, plus the next term is 10C1. 10C1, and here also the remaining portion is nothing but 1 upon 2 whole raised to 10. So we can take 1 upon 10 common from 1 by 2 whole raised to 10 can be taken common from the square bracket, and what remains is now 10C0 is nothing but 1, right, and 10C1 is nothing but 10. So 1 plus 10 is nothing but 11. So that's what will remain common in the bracket. Okay, so therefore finally simplifying this, we have 1 minus 11 whole divided by, now 2 raised to 10 is nothing but 1024. 1024. Now on cross multiplication we will get 1024 minus 11, so that turns out to be 1013 whole divided by 1024. So this is the final answer. Alright, so in this way we calculate the required probability with the help of binomial theorem, and wherever the calculations are tedious we follow the indirect approach and we subtract the probability of unwanted cases from 1. That gives us the correct answer.